Hey guys, my name is Devin. My YouTube channel is DRG Bros. Today we're going to be doing proof of an area of a circle by calculus. So the area of a circle is pi r squared, with r being the radius. That is half of the distance from the center. It's the distance from the center of the circle to the edge. So if we have a circle here with radius r, so this is the radius r right here, and this down here is x, and the distance from where that touches to x is y. And so, by calculus, if we take this area in here, that can be written as x squared plus y squared equals r squared. So we can also, in the form we want to use this, we want to use it another way around. So we're going to separate the y from the r squared and the x. So it's going to be y squared equals r squared minus x squared. And then square root everything. So y is equal to the square root of r squared minus x squared, like that. So we're going to be using this to solve it. So before we start the solving process, let me just remind you that integration with integrals is the area under a curve. So if we were to have a curve like this, for instance, where this distance A and this distance B, and we're trying to find out the shaded area in between, with the curve being the function f of x, like this, then that can be written as the integral from A to B, f of x dx. That is the area of this. So now if we do the same thing with our circle, notice it's the same thing as a curve. This is just this, but backwards. Because you see, I could draw the rest of this as a circle. Imagine this just being this bottom quadrant right here. From 0 to r, with that equation we used earlier, y equals the square root of r squared minus x squared, then we can state that the area of this entire circle is 4, because remember we're going to do all 4, the integral of 0 to r, square root of r squared minus x squared. That's how we're going to, or dx. That is this is the area of a circle, with r being the radius. So now I'm going to show you how this turns into the simpler form pi r squared. So here's how we actually find the area. So we're going to start with 4, integral of 0 to r, square root of r squared minus x squared dx. So we're going to do a bit of a change of variable here. So we're going to let x equal r sine of theta, and dx, so dx equals r cosine of theta d theta, like that. So if we plug that in, that's 4 integral of 0 to r square root of r squared minus r sine of x in parentheses, or sine of theta, my bad, squared r cosine of theta d theta. So now we're going to move the r to the front. So we're going to have 4r, the integral, square root of r squared minus r squared sine squared of theta cosine of theta d theta. Next, if you'll remember from some of our previous videos that I've done, we can rewrite, what's it, the parentheses, same as the beginning, 0 to r. We can rewrite what's in the square root as r squared, parentheses, 1 minus the sine squared of x, cosine of theta d theta. I'm sorry, I don't know why I keep saying x, it's theta, sine of theta. So now we're going to separate the r and the sine of theta, so it's going to be 4r, integral of 0 to r, square root of r squared, square root of 1 minus the sine squared of theta, cosine of theta, d theta. Like that. Alright. So now we're going to start doing a little bit of substitution. So if you remember, again, from my video on, I forgot what video it was. Anyway, this can be rewritten as the sine, as the 1 minus the sine squared of theta. That can be written as the cosine squared of theta. Oh yeah, now I remember. It was trigonometric identities. If you don't know that this can be turned into the cosine squared, just go watch that video. So we have 4r, the integral of 0 to r. R, we're going to do the square root of this. Square root of cosine squared of theta, cosine of theta d theta. Then, the square root and the 2 essentially cancel out. So we have 4r, integral of 0 to r, r, cosine of theta, d theta. Now, here's what we're going to do. Oh yeah, sorry. We're going to, next step, we're going to move this r to the front. So we have 4r squared, integral of 0 to r, cosine squared of theta d theta. Now, again, we have another proof swap. What we're going to do is, if you've seen my previous videos, you'll know that the cosine squared of theta can be turned into 1 plus the cosine of 2 theta over 2 d theta. So then we have 4r squared, integral of 0 to r, 1/2 cosine of 2 theta over 2 d theta. Basically what we did there is we divided the 2 by the 1. So this still needs to be divided by 2, but we essentially pulled this 1 out and then divided it by 2. So it's a little complicated. So next step, we're going to start using some brackets. So it's going to be 4r squared, bracket. Basically what we're going to do now is we're going to split it. So we have the integral of 0 to r, 1/2 d theta, plus the integral of 0 to r, cosine 2 theta over 2 d theta, and close bracket. So now, the next thing we're going to do, we're going to basically pull the 2 out of the other side. So it's going to be, it'll make more sense when I show you. Bracket, 1/2 integral of 0 to r d theta. We're going to move the 1/2 to the front. Plus 1/2 integral of 0 to r, cosine 2 theta d theta. We basically, as you can see from our previous step, what we did is we pulled this 2 out in front, and it became 1/2. Alright, next, we're going to start integration. So it's going to be 4r squared, bracket, 1/2 of theta, bar 0 to r, plus 1/4 cosine of, and here's where we hit a bit of a roadblock. So we actually have to do a u substitution here. So u is 2 theta, and du is 2 d theta. So d theta is du over 2. Now, if you'll remember, I explained this in a different video on integration. This is going to make it tricky to integrate. So we had to do that. So it's 1/4 integral of 0 to r cosine of u du over 2. As you can see from our u substitution. Oh, sorry, no. It's still 1/2. So that's 4r squared, bracket, 1/2 theta, bar 0 to r, plus 1/4, now it's 1/4, sine of u, bar 0 to r. Basically what we did is we took the 2, made that 1/4. Just thinking ahead. Alright, so now we have to do, one more step. We're going to move the 2 back, and we're going to re-integrate, if that makes sense. So it's 4r squared, bracket, 1/2 theta, bar 0 to r, plus 1/2 sine of 2 theta, we're redoing the u substitution, bar 0 to r, and in bracket. Now we have to do another swap. So x is going to equal the r sine of theta, as it did earlier. So x divided by r is going to be the sine of theta, and the inverse sine of theta, x over r, is going to equal theta. So now we can swap theta. So now this is going to be a bit of a mouthful, I'm just warning you. It's going to be 4r squared, 1/2, 1/2 of the inverse sine over x over r, bar 0 to r, plus 1/2 sine of parentheses 2, parentheses, inverse sine, parentheses, x over r, and then 3 parentheses, bar 0 to r, close bracket. Now we can do the next step of the integration, at least for this problem. So what we can do now is we can start replacing these with x. So now I'm going to need 2 lines for this, so you'll see how I'm going to do that in a second. So it's going to be 4r squared, double bracket, 1/2 inverse sine, r over r, see how I can do that because of the integration, minus 1/2 inverse sine, parentheses 0 over r, close parentheses, bracket, then go to the next line, put a plus, and then continue. It's going to be 1/2 sine, parentheses 2, parentheses inverse sine, parentheses r over r, close parentheses, or you actually need 3 closing parentheses, minus 1/2 sine, parentheses 2, inverse sine, parentheses 0 over r, 3 closing parentheses, and a bracket. That was a lot, so I'm going to give you a second so you can copy what I wrote. Alright, so now we're going to significantly cut this down. So it's equal to 4r squared, bracket, 1/2 times pi over 2, remember that the sine of 1 is pi over 2 minus 0 plus 1/2 sine parentheses 2 parentheses pi over 2, 2 closing parentheses, minus 0. And that looks a lot nicer than the 2 line thing we had to do before. Almost done here. Equals 4r squared over pi over 4, because you see how it's 1/2, pi over 4 minus 0 plus 1/2 sine of 2 pi over 2 minus 0. Now, what this turns out to be is, because the 2 and the 2 here cancel, and the sine of pi is 0. Or is it? Yeah, I think it is. Yeah. 4, so we're left with 4r squared, brackets, pi over 4. And as you can see, the 4 and the 4 cancel out, so we're left with, if we bring the pi to the front, pi r squared, our proof to why the area of the square, or the area of a circle formula works. Bye, guys.